Assalamu alaikum. I am Jahangir Alam, lecturer in physics at Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class and carrying on my regular activities. Dear students, I also hope all of you are well with your families by the mercy of Almighty and carrying on your regular studies, staying at home. Okay? Today, we are going to discuss a very important and interesting topic from physics first chapter, that is the chapter of physical quantities and their measurement. Right? Dear student, I know here you can ask what physical quantities and what are their measurement. Right? Dear student, the terms physical here doesn't mean anything related to our body. Here physical means natural, real, not virtual. Okay? And quantity means in our physical world, anything we can measure are known as physical quantity or simply quantity. Right? We can give as example that if I would like to give the idea about the size of my room, I have to measure the length, breadth of the room. So using the length and breadth, you can get the idea about the size of the room. So length and breadth can be measured, so these are the quantity. Similarly, we can measure the amount of substance, that is mass of a substance, energy, work, power, so these are the quantity. Right, dear student? You know, our feelings, our love, our laughter, our sorrow, this cannot be measured. Right? You know, one cannot say, I have a love of 1 kg for you, I have a good wishes of 1 meter for you. This cannot be measured. So these are not quantity. Right, dear student? So now we can see the definition of physical quantity or simply quantity. Okay? Okay. Dear student, so we can define quantity as in this universe anything we can measure is called quantity or physical quantity. As for example, length, mass, time, area, volume, velocity, etc. can be measured. So these are the quantity. Okay? Dear students, now we can see the definition of measurement as to compare a quantity with a standard value is called its measurement. Right? Dear student, suppose if we would like to measure the length of this room or breadth of this room, we have to compare the total length with a standard value. Suppose this is the standard value and this is called meter scale. So here meter is the standard value. Meter has a specific length. We can compare the total length with the meter scale. If the total length is 5 times of the meter scale, then we will say the length of the room is 5 meter. Right? If the total breadth of the room is 6 times, then a standard value 1 feet, then we can say that the breadth of the room is 6 feet. Okay? And the standard value with which we can compare a quantity to determine its amount is called unit. Yeah? The unit of the length is meter because we are comparing the total length of a substance with a standard value which is known as meter. Yeah? The standard value meter is called unit of length. Right? Dear student, now we see the classification of quantity. Basically quantities are divided into 2 categories. First one is fundamental quantity and second one is derived quantity. So what are the fundamental quantities? The quantities which do not depend on other quantities are known as fundamental quantity. As for example, length, mass, time, temperature, etc. There are 7 fundamental quantities. Because this quantity, length, mass, time do not depend on other quantity. Okay? On the other hand, derived quantity, the quantities which depends on 2 or more fundamental quantities are known as derived quantity. As for example, force. If we would like to measure force, we have to depends on mass and acceleration. Right? Again, acceleration depend on time and distance. Similarly, velocity. Velocity is a derived quantity. It depends on distance and time. Work. Work is a derived quantity depends on force and displacement, right? So these are the derived quantity. Okay, dear student, I hope you got it. Students, already we have discussed that there are 7 fundamental quantities, and the quantities are length, mass, time, electric current, temperature, amount of substance, and finally luminous intensity. These 7 fundamental quantities do not depend on other quantities, right? So we have to memorize these 7 fundamental quantities because these are very important. At the same time, we have to know what are the units used for the fundamental quantities, right? For the length, the unit is meter, and for the mass, the unit is kilogram, time, second, electric current, ampere, temperature, Kelvin, amount of substance, mole, and luminous intensity is used by candela, right? And the symbol which denotes the fundamental units of the fundamental quantities, right? For meter, we use the symbol simply small m, and kilogram denoted by kg. The short form of kilogram is kg. Second is denoted by the symbol s. Ampere is denoted by the symbol A. Kelvin is denoted by the capital K. Capital K. Mole is denoted by its short form MOL, mole, and candela is denoted by CD. Right? Dear students, these are very important. This part is very important for your exam. So you have to memorize the fundamental quantities, their units, and the respective symbols, because these are very important for your MCQ exam. Right? I hope you got it. Dear student, now we will see an important definition, dimension. Right? The power of different fundamental quantities in a quantity is called dimension of the quantity. Dear student, first we have to know what are the dimension for the 7 fundamental quantities. Right? First we see the dimension of 7 fundamental quantities, then we will see the dimension of other derived quantity. Okay? Dear student, here are the 7 fundamental quantities and their respective dimension, right? For the length, the dimension will be capital L. Okay? For mass, the dimension will be capital M. For time, the dimension will be capital T, right? The electric current, for the electric current, the dimension will be capital I. For the temperature, the dimension will be theta. Amount of substance, for amount of substance, the dimension will be capital N, and finally the luminous intensity, the dimension will be capital J. So observing this quantity or symbol L, M, T, if L is present in a quantity, then we can say that the quantity is derived from length, or the quantity includes length. Similarly, if a quantity includes M, so we can say that the quantity is derived from mass, or the quantity includes mass, right? So we have to know, or we have to memorize the dimension of the 7 fundamental quantity, right? Dear student, now we are going to see some derived quantity and their dimensions. Dear student, now we are going to see some derived quantities and their respective dimension. First, we will see the velocity, right? We will learn what velocity is in our next chapter. Velocity is defined by the distance traveled in unit time. So velocity can be expressed as length or distance by time, and velocity is denoted by small v. So therefore the dimension of velocity can be expressed as L by T or L T inverse 1, right? That is, if a quantity is enclosed by third bracket, then it means that it indicates the dimension of the quantity. So here V is enclosed by third bracket, it indicates the dimension of velocity. So dimension of velocity will be L T inverse 1. Now we will see the acceleration. In our next chapter, we will see acceleration is defined by the rate of change of velocity. It's called acceleration. So acceleration can be expressed as change in velocity or simply velocity divided by time. Right? Dear student, already we have learned the dimension of velocity is LT inverse 1. So here velocity is divided by time and acceleration is denoted by small a. So dimension of acceleration will be velocity divided by time. Here velocity, dimension of velocity is LT inverse 1, LT inverse 1 divided by time. So finally it will become LT inverse 2. Okay. Now we are going to see another quantity, force. Force can be expressed as mass multiplied by acceleration, right? Dear student, you know the dimension of acceleration is LT inverse 2 and the dimension of mass is capital M, right? So if we show the dimension of force, here F indicates force. So dimension of force is M multiplied by acceleration. Dimension of acceleration is L T inverse 2. So it will be M L T inverse 2. Right? Now we are going to see another derived quantity, work. Dear student, work can be calculated as by the product of force and displacement, right? Therefore, work is denoted by W, so its dimension will be force multiplied by displacement. Here the dimension of force already we have derived here, M L T inverse 2 multiplied by displacement. Displacement means distance, whose dimension is L. Therefore, the dimension of work will be M L square T inverse 2, right? Dear student, the dimension of this quantity are very important for your exam, right? I hope you got it and you have to practice by yourself from your textbook. Dear student, now we are going to see a very important and useful measuring instrument, which is vernier scale and slide calipers, right? Suppose we are going to measure the length of this marker using this scale, right? And in that case we have to place one end of the marker at the 0 mark of the scale and other end we have to observe the mark of the other end. If the other end of the scale coincide with 135 millimeter, then the length of the marker is 135 millimeter. But if the length or other end of the marker lies between 135 and 136 millimeter, that is the length of the marker is more than 135 millimeter and less than 136 millimeter, then what will be the accurate length of the marker, right? To solve this type of problem, scientist Pierre Vernier invent a scale which is known as vernier scale, right? Actually, if we see this instrument, this is known as slide calipers. Actually, vernier scale and a main scale combinedly known as slide calipers. individually the vernier scale is useless. Here you can say this scale, this small scale which can slide over the main scale is called vernier scale, and combinedly these two scales are known as slide calipers, because here the vernier scale can slide over the main scale. That's why this is called slide calipers. The main characteristics of the vernier scale or slide calipers is that the total length of 9 division of the main scale equal to the total length of 10 division of the vernier scale, or total length of 19 division of the main scale equal to total division of 20 scale of the vernier scale. Again, the total length of 49 division in a main scale is equal to total length of 50 division in a vernier scale. So vernier scales are made on this basis of principle. Here, when usually the main division or zero mark of the vernier scale coincide with the zero mark of the main scale, right? Here we have to know another important term which is known as vernier constant. Dear student, vernier constant is mainly the difference of the value of one division of main scale and that of the one division of vernier scale, right? That is the length of one division of the main scale and that in the or the length of the one division of the vernier scale. Difference of these two value is known as vernier constant. It has a mathematical expression. The vernier constant is denoted by VC. VC can be expressed as length of one division of main scale divided by number of division of vernier scale, right? So usually the length of one division of the main scale is denoted by S and the number of division in vernier scale is denoted by small n, right? So dear student, in this instrument the length of one division of the main scale is 1 millimeter, and number of division in the vernier scale, is 20. So if we divide 1 millimeter by 20, so it will be 0.005 millimeter or 0.005 centimeter. So this means that we can measure the length of an object up to 0.005 centimeter accurately, right? So now we can see the definition of vernier constant. It is the difference of one division of the main scale and one division of the vernier is called vernier constant. It is a very important definition for your exam. Okay, so I hope you got it. Now we are going to see an important term, vernier coincidence. Okay, dear student, if we would like to measure the width of this measuring scale, then we have to place the scale between the two jaws of the slide calipers, right? Suppose we have to place the scale in this way between the two jaws of the slide calipers. Dear student, in that case the zero mark of the vernier scale crosses 4.4 centimeter. 4.4 centimeter. Here the zero mark of the vernier scale crosses 4.4 centimeter. So main scale reading is 4.4 centimeter. To measure the fractional value, we have to observe the which mark of the vernier scale coincide with the main scale. Here 12 mark of the vernier scale. There are 20 division in the vernier scale. 12 mark of the vernier scale coincide with any mark of the main scale. So this 12 mark is the vernier coincidence, right? So we can say that any mark that is the mark of the Vernier scale. Mark of the Vernier scale which coincide with any mark of the main scale is called Vernier coincidence. Right here 12 mark of the Vernier scale coincide with any mark of the main scale. So here coincidence of Vernier coincidence is 12. So we can give the definition of Vernier coincidence as the mark of the Vernier scale which coincide with any mark of the main scale is called Vernier coincidence. Right? Now we are going to see how can we measure the length of an object using a slide calipers. Right? Dear student, we have to use the expression or formula to measure the length of any object. Length or breadth or height here is equal to m plus v multiplied by vc. Here m indicates the main scale reading. M indicates main scale reading. V indicates Vernier coincidence. Already we have know what is Vernier coincidence multiplied by Vernier constant. We have also know what is Vernier constant. Right, dear student? Suppose we are going to measure the width of the measuring scale. So in that case we have to place the scale in between the two jaw of the slide calipers. So here the 0 mark of the Vernier scale crosses 4.3 centimeter. Right? So in the main scale, which mark is crossed by the 0 mark of the Vernier scale is the main scale reading. That is, the main scale reading is 4.3 centimeter. So we can write here main scale reading AM is equal to 4.3 centimeter. Right? And here the division of the Vernier scale 14. In that case 14 mark of the Vernier scale coincide with any mark of the main scale. So here Vernier coincidence which is denoted by V. So here V is equal to 14 and we know the Vernier constant of the slide calipers that we have calculated in our previous calculation. Vernier constant is 0.005 centimeter. Right? So Vernier coincidence have no unit. So the width of the scale can be calculated using this expression. So width or breadth is equal to main scale reading plus Vernier coincidence multiplied by Vernier constant. Here main scale reading is 4.3 centimeter plus Vernier coincidence is 14 multiplied by 0.005 centimeter. Right? So it will be 4.3 centimeter and the product of the two value is 0.07 centimeter. So final calculation will be 4.37 centimeter. Right? Dear student, this is the actual width of the measuring scale. Right? Dear student, now we are going to see a mathematical problem. Okay. Here is our mathematical problem. In the question they said that in the measurement of length of a rod by slide calipers, the main scale reading here the main scale reading is 14 centimeter. Vernier coincidence is 7 and Vernier constant is 0.01 centimeter. What is the length of the rod? The information or data given here. Here the main scale reading which is denoted by capital M. Main scale reading M is equal to 14 centimeter. Right? Vernier coincidence which is denoted by V is equal to 7 and Vernier constant which is denoted by VC, V is equal to 0.01 centimeter, right? So we have to determine the length of the rod. We know length L is equal to, the expression will be M plus V multiplied by VC, right? Here M is 14 centimeter plus V is 7 multiplied by 0.01 centimeter, right? So 14 centimeter plus 0.07 centimeter. So it will be 14.07 centimeter. Dear student, this is the actual length of the rod whose description is given in the question, right? So I hope you got it, dear student. Thank you very much being with me in my class. So may Allah bless all of you. Assalamu alaikum.